Hi, my name is Corey Snar, and this is the video explaining the project that I'll be sending in with my application. I have deep interest in renewable energy sources, so I decided to make a solar tracking system. For this project, I use an Arduino as my control board. As you can see here, I have two voltage dividers with a photoresistor and a regular resistor that lead into the analog inputs of the Arduino. The analog inputs of the Arduino have 1024 bits of resolution, so the first thing I had to do was find the correct resistance on the regular resistors to get the most bits of resolution I possibly could.
Okay, so I found that 33K was the best resistance to get the most bits of resolution, and we can test this by going to the Arduino program and opening up the serial monitor and seeing that, first of all, the values are pretty close when they're in an identical area. Not too many bits of resolution off, and then if we put it in complete darkness, you can see that the bits will go just about to 0, and then if we make it as bright as possible, then the bits go to approximately 1,000. Alright, so if we take a look at my code, the first thing you'll see is that I included the stepper library. The stepper library is one included in the Arduino program that's specifically meant for driving step motors. After that, you'll see that I declared steps per revolution, and there is 4096, which means that it takes 4096 to make one full revolution for the step motor. Then you'll see that main pin equals 0. Main pin is the 90-degree photoresistor, and that's attached to analog pin 0. And then there is test pin, which is equaling 1. That means that the 75-degree photoresistor is attached to analog pin 1. And then if we come down here, we have stepper, which is a declaration of your step motor that's required for the library that I'm using. And you'll see I declared solar step. That's using digital pins 8, 9, 10, and 11. Then I have my setup loop, which is required format for all Arduino programs. And you see that I have the baud set to 9600, which is normal baud. And then in the loop, I have two print lines that print out the values for main pin and test pin, the analog reads, which I showed you earlier. And then from those, I transfer those to another variable, so that way my if statement will work. And I have the if statement set up so that you can see if the straight read, so the main pin, if it is less than the off read or the test pin, then it uses this while loop to make the step motor move. And then it moves 169 times because that's 15 degrees of move. And then there is a 5,000 millisecond delay, and it resets the step counter to 0 so that the while loop will work again.
This is the setup for the solar tracking system. As you can see here, I have a container with my Arduino, which we already talked about in there, and the breadboard with the two voltage dividers. And as you can see, I have the wires leading out for the photoresistors. And also you can see in here I have my step motor driver. Step motor driver is connected to pins 8, 9, 10, and 11, and it just makes it easier for the coding to have a driver. Also you can see there's a battery in here which is going to power the whole thing. And coming out we have the step motor, which is also connected, and you can see the frame on top of the step motor and the solar cell. And from here you can see the two ports where the photoresistors are sitting in. I have one at 90 degrees and another one at 75. Solar cells have an angle of incidence of 15 degrees in all directions. So if the solar cell gets out of that 15 degree range, it will see it right here with this photoresistor, and then it'll move back in that 15 degree range.